Good morning, biologists. This is your first circuit breaker lesson on May the 28th. We are going to start the lesson by opening up your spiral bound class workbook onto a yellow page, and let's do a warm-up question. So I've just written here, I would like you to consider which takes longer to protect an individual against a specific pathogen. Is it exposure to the antigen or administration of antibodies as a treatment? So which one is the slower or takes the longest? Before you start to respond to this question, I want you to think about a few things. If I can just click on the PowerPoint. Firstly, what are we talking about? What do the terms mean? Exposure to the antigen or administration of antibodies. Does that help you to connect to a particular dot point in the course? What are we actually talking about here? What key terms? This is a 50-50 answer. So you could get, obviously you could answer exposure to the pathogen or antigen, or you could choose administration of antibodies. Neither of those two will give you a mark. It's important to know that if you are post a 50-50 by VCAR, it's the justification that gets you the marks. So how do you construct this answer? Firstly, think about the mark allocation. If it's a 50-50, you need to go to the next step. The place that those marks are going to come from, you need to make a statement explaining your choice. So still make a choice. If you think it's exposure to the antigen, state that. If you think it's using antibodies as treatment, state that, and then explain why. The second mark will be about why the second one, the other alternative, is not correct. Okay, so you're making a watertight argument, and that's where those 2 marks will come from. If there are specific terms in the question or in the study design, please use those. Okay, so we're talking about types of immunity here, so it would be really good if you could use those types of immunity in your response. Press pause for 2 or 3 minutes while you construct an answer, and then join me again. Okay, so I'm going to assume that you have now recorded your answer in your yellow page. The answer to the question, which one takes longer to protect an individual? Exposure to the antigen will take longer. Now, whether that is a vaccination or natural exposure, they're both producing active immunity. So you need to initiate or activate the specific immune system. So activate the lymphocytes, and that's a very slow process, as we know. It will create immunological memory, so it will produce much stronger immunity and long-lasting immunity. However, it is slower, whereas administration of antibodies is artificial and passive, and that is much, much quicker. It will provide immediate treatment, so it will deal with the pathogen and protect the individual immediately, whereas the other one is much slower. But that immediate protection will vanish after an amount of time because free antibodies don't circulate in your system for very long. Make sure that you have included in your answer the words that describe the type of immunity. So exposure to the antigen could be natural active or artificial active if it's a vaccination, whereas administration of antibodies is artificial and passive. Okay, make sure you have 2 sentences, one explaining why exposure to the antigen is slower, and one explaining why antibody treatment is not the slowest of the 2. Okay, moving on. So what I'd like you to do is we're just going to refresh our memories from yesterday in the first part of today's lesson, or however you choose to organise your day. I'd like you to firstly sketch these 2 graphs. Now you can stay on your yellow pages. We've nearly finished the course, so you have plenty of space in the yellow pages. You can do it in there, or you can do it in your notebook where you're making notes from Idrolo and Biozone. But I'd like both of these graphs sketched in your book. And then what we will do is you'll need to describe those 2 graphs. So pause the video while you sketch these 2, making sure that you've annotated them just as they are done here. I would put them next to each other as shown, and I would give them graph 1 and graph 2. Again, please pause the video while you do that, and when you unpause, in fact, before you pause the video, please describe the graphs. So notice what we've got here. So it relates to the question that you've just done in your yellow books. Here we've got on both of the graphs, the y-axis is the concentration of antibodies. Now here we've got a specific antibody. They've actually named the pathogen, whereas here it's just a general graph. The x-axis in both scenarios is time. What I'd like you to do for graph 1 is explain this first peak. What's happening here in this decline after the primary immune response? So what's actually happening? What's causing that to happen? And then describe the secondary immune response. Then in graph 2, have a look at this and actually tell me what you think is happening. So here we've got, have a look at the antibody levels in the first 30 days. What's happening, do you think, at this point? And then describe the change over the following, 90 days, from 30 to 120. Okay, pause the video, and then when you press play again, I will give you a model answer, and please check that against your descriptions of the graph. Really, really important that you learn to describe the graphs of immunity in the correct terms and very specifically. Okay, so describing graph 1, and then underneath graph 2, underneath your sketch, describing graph 2, and then press play. Okay, so this is my explanation of graph 1. It's popped up over the top of graph 1, but I'm sure that you've drawn it in your book, so you'll be able to just check your description against mine. I've said that graph 1, you can see the primary response results in slow activation and slow increase in antibodies. That's because the lymphocytes are activated very, very slowly. Okay, remembering that there are very few lymphocytes with the specific antigen that will match the pathogen at first. So at this point, we've got no immunological memory. So we've only got a few lymphocytes, a few B and T lymphocytes that actually match the antigen presented. As a result of that, the production of antibodies is quite low as well, because you're only activating a few cells to start with. Remembering which cells produce the antibodies, that relies on the activation of naive B lymphocytes in the lymph node most likely, to differentiate into memory lymphocytes and plasma B cells, which then produce the antibodies at a fairly high rate. But still, if you've only activated a few B lymphocytes, you get a low antibody level at first. Now, why did the graph dip? That's because the circulating antibodies aren't long-lived. The only antibodies that remain, so the only reason that primary exposure or the concentration of antibodies doesn't go down to 0 is because there are membrane-bound antibodies on your memory cells. Okay, so it doesn't go back down to 0. It will stay at a low level. But all of the circulating antibodies will be broken down by your body. Secondary exposure is quicker due to the presence of immunological memory or memory cells. Now, memory cells, because there are more of them, they will encounter that pathogen more quickly than if there are only very few. So remembering that the pathogen circulates in high levels and will encounter the pathogen quickly. So the memory cells will encounter the pathogen more quickly and therefore become activated and start producing antibodies more quickly than in the primary response. The levels will be much, much higher. So it's a faster response because of the presence of those memory cells. And it's also a higher magnitude response due to the fact that you've got more effector B cells or plasma B cells to make the antibodies there. Graph 2 shows, if you've given me some numbers on your graph and on your sketch, shows that there are no antibodies for the first 30 days. And then there's a vertical line. So it goes from 0 up to a very high level of antibodies immediately. And what that indicates is that you don't have that slow response, that slow incline. It indicates that it's the administration of antibodies from another source. Okay, so describing the graph showing that it goes from 0 to very high, indicating the administration of antibodies from somewhere else, which is describing or indicating that this is artificial passive immunity. The last thing I will get you to do is describe this multi-dose vaccination graph. Okay, so here I'm just going to move that away. So here you can see a replication of the graph that we've just drawn. So we've got administration of, it looks like a vaccine here, first dose and second dose. So sketch this much more complicated graph in your notebooks and show this target for reliable protection. So this is where we consider protection to be quite good after the vaccination. You can see that it's not reached after the first dose, but after the second dose we achieve what we consider to be a good level of immunity. This is the important thing. I would like you to then, we've got an axis break, so this indicates that it could be a much longer time down the track when immunity starts to wane or decrease. And after that, a booster injection is required to achieve that target or that reliable protection. So here what I'd like you to do is sketch this and then describe the difference between a multiple dose vaccination. So here we've had to give 2 doses to achieve an acceptable level of immunity. But then after a long period of time, that immunity begins to wane or decline to a point which is lower than we accept. So after that, it's really important that we give a booster injection to again achieve immunity in the population or in this individual from this graph. You don't need to worry about the variance, so you can stop your graph here. We can talk about that together later. But this is a graph where you will distinguish between a multi-dose vaccine, which is used as part of the regime to give immunity in the first place, and the administration of a booster injection, perhaps even 10 years down the track, to actually restore immunity in individuals who were at first immune due to their initial vaccines, but that immunity has started to wane and has dropped below what we consider to be an effective level. Okay, well done. That is your lesson for today. So please message me if you have any questions. Otherwise, move on to any other tasks that I've set you in Teams.